Alright, number 1380 lucky numbers in a matrix. Given an n by n matrix of distinct numbers, return all the lucky numbers. A lucky number is an element of the matrix such that it is the minimum element in its row and maximum in its column. Okay, how are we gonna do this? Seven is the only lucky number. Okay. Three, 7, 9, 11, 13, 16, 17. So it has to be the minimum element in, is it sorted? 1, 10, 4, 2. Okay, so it's not sorted. I reckon that there's some trick here to get this to work really nicely. But to start, what are we gonna do? We iterate over the first row, find the smallest number, and then check if it is the maximum in the next. If it is, we check the maximum in the next until we know whether it is lucky or not, and then we do the same for the next. But we're gonna have to check above as well. So 9, we'd have to check if 3 is bigger. Like say this was a 1. We'd have to go 7. Is it bigger than 7? Is it bigger than 16? This doesn't seem like it's that easy. This doesn't seem like it's easy at all. Alright, I'm just gonna start coding to see what we can do. So rows equals len of matrix naught cols. That's cols. And rows equals len of matrix. So real quick, print cols rows should be 3, 4. No, 3, 3. Oh, that's not helpful. Here it will be 4, 3. Okay, got that right. That is exactly what we need. So how do we take the minimum element from a row? First, we're gonna need to do for underscore for I in range. We're gonna need to iterate over each row. And that is going to be, my bad. So this is going to get us to iterate over each element in the list. How do we just get the So if we grab our minimum element, then we need a way to check what row this is in. So we can do for j in cols, if j is equal to the min value, row col okay, so this should just print 3399 1515. Cool. This is a really slow way of doing this, but I think to start I have to just brute force and then fix it up from there. Okay, so I know how to find my column value. Then I need to do a triple for loop is so devious. Oh, that is actually smart. Min row. Okay, this is extremely helpful. So we can just do min underscore row dot append min of matrix I. Then we can do max underscore col. For j in range cols max underscore col dot append. Okay, wait, no, here. Now we need to do print matrix I j. This is just going to print it row col 3, 7, 8, 9, 11, 13, 15, 16. That's not what I want. Okay, wait, so that gives us our minimum row. Then we do for I in range cols print Why is this giving me such a headache? Should be going 1-9. Okay, wait. So I need to go I is equal to 0, j equal to 0, 1, 2. I will print the rows. J will print the cols. Yeah, so it does need to be rows. While I is 0, J will move. Yeah, okay. Cool. Can you do it like this? Minus infinity Python. Excuse me. Float minus inf. If matrix ji greater than max underscore val max underscore val will equal matrix ji and then after this for loop we do max underscore col dot append max underscore val print min underscore row max underscore col, and this should go row 0 col 0 row 1 col 1. And then you compare. Whew. That was too conceptually difficult. The matrices. I don't know why that hurt my head so much. So then we can just do for I in min of min underscore row. If len of min underscore row less than len of max underscore col, we can do for I in min row if I in max col res dot append I, else for I in max col if I in min underscore row res dot append I. turn res. Alright. That was way harder than I thought it would be. Yeah. Alright. Cool. Clearly need to revise matrix operations. Because going over columns was so much harder than it should have been. But yeah, cool, it works. Awesome.